Hey there! Turn on your speakers. Do you have finals week coming up? Projects due? Homeworks are piling up? Are you freaking out that you're getting boxed in with deadlines? Here's an idea. Get help. Think Geek Exams. Find us on Facebook, Twitter, or YouTube.
Hi, so this is our project. It's a statistics tool project. This is from a client of mine who is in a university doing this project. This project has 5 problems, and they are labeled A, B, C, D, and E. So there's going to be at least 5 videos. Today we're going to try to do problem A in one video. This project also has documentation section that has to be done in latex. We're not going to deal with that. We're just going to deal with R over here. So one of the best ways to learn R is through RStudio, which I downloaded recently. For this project, you have to install the ggplot tool, which is required. So I installed it by clicking on this, and just it does its thing. So the first thing that this problem is, it's data management problem, and there are n observations which are normally distributed, and we have to find the closest 2 observations in value, closest in value, and we have to find their distance, and we have to find the indices of these close observations. And we are told that we can use order, diff, and which.min and rnorm to create the samples. So right off the bat, let's find out. Let's type in how many samples we're going to have. We're going to have 20. 20 n equals to 20 l. L means it's an integer. Then x is r norm, and we need n samples. And then we need to do I. I goes from 1 to n. These are the indexes for x. So let's run this. This will create n, which is 20, x, which is a randomly distributed variable, and I, which is integers going from 1 to n. Alright, next we are going to put these in a data frame so that I and x can be together. So we call the function called data frame, and first we put in the i's, and then we put in the x's, and that basically will do it for us. I'm going to copy this over here, and then I'm going to run the df command, and you see that i's are in sequence and the x's are also. They're not ordered, but it's a sequence. And what we need to do next is we need to order these x's. And the way we're going to order them is first we need to basically find the order that they are in. So we'll order these and put the indexes in that order. And so we're going to access the x's through the df data frame, so that i's are also going to get ordered if I need it to be ordered. So we're going to order them and store the indexes in ndx. And this is the command to do that. And that's the command. And you will see that ndx is just indices, and they are in. So 3 is supposed to be the smallest one. So minus 1.489 is going to be the smallest one. Next one is going to be minus 1.37. Okay, so that looks right. Next, what we're going to do is we're going to take these indices and we're going to create a new data format called df sorted, and they are just going to be df sorted by ndx. And this is the command to do that, and we're going to run this command. And that's the cool part about R. We can just run this on this screen, and notice that the indices are now ordered according to increasing order of x. Okay, so now we're going to find the distance between each of these pairs, the adjacent pairs. We're going to find the distance between this one and this one, this one and this one. And so there's going to be 19 samples for differences. So the way we're going to do that is dx equals to diff. We're going to use the diff command here. And here we're going to do df sorted, and we're going to use the x's. Okay, so now this here will give us the distance between the x's in adjacent sorted x's. And dx looks like this. Notice that they are obviously not going to be in order, but they are very small numbers. We have to find the smallest number here. And the way we do that is with the command called which.min. And so min dx is going to hold the index for the minimum dx, which.min is going to find it for us, and we're going to find it in dx. So let's do that. Min dx now holds an integer that is 9, and we can see that 9 is 0.0048. Yeah, that looks small enough compared to the rest of them. Alright, so notice that these are all positive numbers because all of these are in increasing order, so they have to be in positive numbers. Alright, next what we're going to do is we're going to, now that we have the answer for min dx, we're going to print out. I have already printed out so the closest IDs are, oops, oh, I typed it wrong. Let's do that again. Min dx is small x here and small x here. That should work. Alright, next, so these are the minimum dx's, the IDs for them. Next, we are going to get the values for them, and the values are small x here and small x here. That should work. And those are the values. Look, they're pretty close to each other. And next, we are going to find the actual distance between them. And this is also min dx small, and that should give us the closest distance. And that value is the same as this value over here. And if I were to subtract this from this, it should give me the same value. Something went wrong. Yeah. So this value and this value are the same. Alright, so that finishes the requirements for problem A. We found the indices. They are 18 and 13. We found the observations, which are this number and this number, and we also found the closest distance, which is the distance between this and this, and we checked that that is the right distance, and that is the closest distance. These are the closest observations, and these are their IDs. Thank you very much. Come back later. Thank you.
Think Geek Exams. Our agents have Masters of Engineering degrees from MIT, Stanford, Georgia Tech, Caltech. We give you solutions to mathematics, physics, computing, and engineering. Find us on Facebook, Twitter, or YouTube.